Bismillahirrahmanirrahim. Assalamu alaikum. Multiplication of matrices are discussed in previous video lecture. Before to discuss the new topic in this video lecture, I briefly take an example of two matrices and perform their multiplication. In last video lecture, if we are multiplying two matrices, so this multiplication is possible only if the number of the columns of the first matrix, mean the first matrix in this multiplication is A, is equal to the number of rows of the second matrix. Number of rows of the second matrix. Then these two matrices are said to be compatible for multiplication. So if the order of a matrix A is, let's say, M by P, and the order of matrix B is, let's say, P by N. So you see that here in this product the order the number of columns of matrix A is P, and the number of rows of a matrix B, which is second in this multiplication, is also P. So you see that the number of the columns of first matrix is equal to the number of the rows of second matrix. So A and B are conformable for multiplication. From this multiplication you get another matrix C. The order of matrix C is determinant by taking the rows of the first matrix and the columns of the second matrix. So the resultant matrix which is obtained from the multiplication of these two matrices having order M by N. This M is the number of rows of the first matrix and N is the number of the columns of the second matrix, which is B in this multiplication. Now I am taking a specific example to perform this multiplication. Let's say a matrix A is 3 1 2 2 1 3, and let's say matrix B is 1 2 3 1 2 3. So you clearly see that the order of this matrix is 2 by 3 and the order of this matrix is 3 by 2. If you need to perform the product of A with B, mean you are multiplying A with B, so your A is a first matrix and B is the second matrix. So in first matrix you will see the number of columns, so there are 3 number of columns, and in the second matrix you will see to the number of rows, so there are 3 rows. So the number of the columns of the first matrix are equal to the number of the rows of the second matrix. So the product of these two matrices is possible. Now how you can find the product? So you need to multiply the rows of the first matrix with the columns of the second matrix one by one. You will multiply, let's say from this product you get as matrix C. So in this case you will multiply the first row with the first column. So this element will be multiplied with this one. This is the first element of the first row and this is the first element of the first column. First you will multiply first row with first column, then multiply first row with second column. So when you are multiplying first row with first column, you will multiply 3 with 1 because this is the element of matrix A in first row and first element of that first row, and this is the first element of the first column. So 3 will be multiplied with 1, then you will write plus 1 will be multiplied with 3 because this is the second element of the first row and this is the second element of the first column. And similarly 2 will be multiplied with 2 because this is the third element of the first row and this is the third element of the first column. So when you multiply first row with first column, so in the resultant matrix C, the sum of the product of the corresponding elements in the first row and first column will be written here in the place of element having present in first row and first column. Then you will multiply the first row with second column. So 3 will be multiplied with 2 because this is the first element of the first row, and this is the first element of the second column. So this first element of the first row will be multiplied with the first element of the second column. Then you will put plus sign. The second element of the first row will be multiplied with the second element of the second column. Then third element of the first row will be multiplied with the third element of the second column. So 3 multiplied with 2, and from this addition you get a single number. So the position of that single number, which is the element of matrix C, must be first row and second column because you are multiplying first row with second column. So you see that this lies in first row and second column. Then now there are no more columns, so you will switch to row number 2. Row number 2 will be multiplied with column number 1. So you will multiply the first element of second row with the first element of the first column. So 2 will be multiplied with 1. Similarly, 1 will be multiplied with 3. Then you will put plus sign. 3 will be multiplied with 2. And similarly, when you multiplying second row with the second column, so 2 will be multiplied with 2 because this is the first element of the second row and this is the first element of the second column. You are multiplying the second row with second column, and plus 1 we multiply by 1 and 3 multiplied by 3. So you see that when I multiply the second row with first column and the product is 8, when you sum that product, so you will get from here a single number, and that single number will be the element of the resultant matrix C, and that element must be written in the position having present in the second row and first column because this is get from the multiplying second row with first column, and similarly this is from the second row and second column. So you see that the order of this matrix is 2 by 2 because the resultant matrix contain the number of the rows of the first matrix and the number of the columns of the second matrix. So you clearly see that this C will contain the number of the rows of the first matrix and the number of the columns of the second matrix. So here the rows are 2 and here the columns are 2. So that's why the product of the resultant matrix must be 2 by 2. The order of this must be 2 by 2. So now C is of order 2 by 2, which is actually the product of these two matrices. So from here you will get 3 plus 3 plus 4. This is 6 plus 1 plus 6. This is 2 plus 3 plus 6. This is 4 plus 1 plus 9. So you get C, which is the product of two matrices. This is 10, 13, 11 and 14. So this is of the order 2 by 2. So you see that when two matrices are compatible for multiplication, so their product gives another matrix, and the order of that matrix is determined by taking the rows of the first matrix and the columns of the second matrix. Now if I want to multiply B with A, so here I will check the number of the columns of matrix B, because now this is the first matrix in this multiplication, and the number of the rows in the second matrix because this is the second matrix in this multiplication. So here in the matrix B, the number of the columns are 2, and in matrix A, the number of the rows are 2. So this multiplication is also possible because this is your first matrix in this product, so the number of the columns here are 2, and this is the second matrix in this multiplication, and the number of the rows of this matrix are 2. So this product is also possible. So here B is of order 3 by 2 and A is of order 2 by 3. So the matrix in the resultant, let's say you get a matrix D, so the order of that matrix will be such order in which the number of the rows are equal to the number of the rows of the first matrix, and the number of the columns will be equal to the number of the columns of the second matrix. So how you can perform this multiplication? BA, you will write B first, 1 2 3 1, this is 2 3, and the matrix A is 3 1 2 2 1 3. So the procedure is same. You will multiply the first row with first column. So the first row will be multiplied with the first column, and 1 will be multiplied with 3, and 2 will be multiplied with 2 because 1 is the first element of the first row and 3 is the first element of the first column, and 2 is the second element of the first row and 2 is the second element of the second column, and there must be an addition. So 1 multiplied by 3 plus 2 multiplied by 2, and from this the sum of the product of the first row and first element, first row and second element corresponding elements, which gives you a number which must be written in the first row and first column because it is obtained from multiplying first row and first column. Similarly, first row will be multiplied with second column, so 1 will be multiplied with 1, 2 will be multiplied with 1. Similarly, first row will be multiplied with third column, so 1 will be multiplied with 2 plus 2 will be multiplied with 3, and there is no other column, so then we will switch to row number 2. And similarly, row number 2 will be multiplied with column 1, then column 2, and then column 3. So when you multiply second row with first column, so the number which you obtain from that multiplication will be written in a place having second row and first column because this is obtained from multiplying second row and first column. So 3 will multiplied with 3, then plus 1 will be multiplied with 2. Similarly, second row with second column, so you clearly see that this must be written in the second row and second column. Then second row, third column. Now there is no other column, so we will switch to row number 3. So row 3 with row column 1. So 3 multiplied 2 multiplied 3 plus 3 multiplied with 2, and then 2 multiplied by 1 plus 3 multiplied by 1, and then 2 multiplied by 2 plus 3 multiplied by 3. So from here you get let's say matrix D. This is 3 plus, this is multiplication, 3 plus 4 7, 1 plus 2 3, 2 plus 6 is 8, 9 plus 2 11, 3 plus 1 4, 6 plus 3 9, 6 plus 6 12, 2 plus 3 5, 4 plus 9, 13, and you clearly see that the order of this is 3 by 3. And before the multiplication I explained that the order of the resultant matrix must be 3 by 3, because the order of the resultant matrix is actually determined by taking the rows of the first matrix and the columns of the second matrix. So here the rows are 3 and here the columns are 3, so that's why the order of this must be 3 by 3. So that's this is the way to multiply two matrices. But remember, now from here we get a very beautiful point from here. You see that when I multiply A with B, you see that A with B, so I get this matrix 10, 13, 11, 14. And when I multiply B with A, so I get this matrix 7, 3, 8, 11, 4, 9, 12, 5, 13. So you clearly say from these two that AB is not equal to BA. So what does it mean? This AB not equal to BA is actually commutative property. So you from here we say that commutative property with respect to multiplication is not true in the set of matrices. Commutative property, non-commutative property. This is non-commutativity. So the set of matrices does not hold the commutative property with respect to multiplication. You clearly see it from here that A multiplied by B is not equal to B multiplied by A. So this is an important point. The set of matrices does not hold the commutative property with respect to multiplication. You cannot say that the product of every two matrices is commutable. Mean if you multiply A with B or B with A, you will get the same result. No, in case of the matrices this is not true. In case of a real numbers, complex number, that are true, but for the case of the matrices the commutative property with respect to multiplication is not true. With respect to addition it is true. So this is an important point. Thank you.